Alright, in this video we're going to be looking at type 1 and type 2 errors for discrete. So the definitions remain. A type 1 error is when you reject H0 when it is true, when H0 is true. And then a type 2 error is when you do not reject H0, when H0 is false. Alright. And so under discrete conditions, the probability of a type 1 error is simply the probability of being in the rejection region. So you'd have to first find the rejection region and then find the probability of being inside of that rejection region, and that gives you your type 1 error. And then for a type 2 error is the probability of not being inside that rejection region given a change or a correction in our population parameter. So a change in our population probability or population mean. So let's look at some examples. Here we're given that a national survey shows that 95% of Year 12 students use social media. Arvin suspects the percentage of Year 12 students at his college who uses social media is less than the national percentage. He chooses a random sample of 20 students at his college and notes the number who use social media. He then carries out a test at the 2% significance level. Part A, find the rejection region for the test. Okay, so let's define our random variable x. X is the random variable, that's the number of students who use social media at Arvin's college. So number of students who use social media, at Arvin's college. So what are our null and alternative hypotheses? H0 would be that the probability is the same as the national percentage, which is 0.95. And then H1, what is Arvin's suspicion? He suspects that this is less, so P is less than 0.95. So our distribution here is that X follows a binomial distribution with N, his sample size being 20, and P being 0.95. Alright, so the rejection rule for his test would be reject H0 if the probability that X is less than or equal to our critical value is less than our significance level, which is 0.02. So this here is what we're going to use to help us determine our rejection region. We need to find this critical value C, because that will give us our rejection region. If X is less than or equal to C, we will reject H0. So to find our critical value C, we're going to use trial and error until we get the first value of C that gives us a probability that is less than 0.02. Maybe we can start off with a probability that X is less than or equal to 1 and see what that gives us. So this is going to be 20 choose 1 multiplied by 0.95 to the power 1 times 0.05 to the power 19. So this would give us, let's punch this into the calculator, 20 choose 1 times 0.95 times 0.05 to the power 19. Alright, this is far too small. This is 3.62 times 10 to the negative 24. Seeing that this probability is so small, it probably means that our distribution, most of the area of our distribution is on the right side of our distribution. So we're probably looking at something like this, right? It's continuing to increase as we go on. So most of the area is going to be on the right hand side of our distribution and a very small area on the left hand side. So let's try a value that's very close to our upper bound. So that's very close to 20. We could try the probability that x is less than or equal to 19 and see if this is closer to 0.02. So that's going to be 1 minus the probability that x is greater than 19. So that's 1 minus the probability that x is 20. So that would be 0.95 to the power 20. That's 1 minus 0.95 to the power 20. And this here, okay, this is 0.642. Okay, so it means that maybe we're now getting closer. So this is closer, this is much closer to 0.02 than this 3.62 times 10 to the negative 24. So it does mean that the bulk of our area is going to be on the right side of our distribution. Since we want a smaller probability than this 0.642, let's reduce the value of c. Let's try maybe x is less than or equal to 17 and see what that gives us. So this would be 1 minus the probability that x is greater than 17. So that's going to be 1 minus x is 18, 19, or 20. So 20, choose 18, multiplied by 0.95 to the power 18, multiplied by 0.05 to the power 2, plus 20, choose 19, multiplied by 0.95 to the power 19, times 0.05 to the power 1, plus 0.95 to the power 20. Alright, and so if we punch this into the calculator, that's 1 minus 20, choose 18, multiplied by 0.95 to the power 18, times 0.05 squared, plus 20, choose 19, times 0.95 to the power 19, multiplied by 0.05, plus 0.95 to the power 20. Alright, so this is probability that x is less than or equal to 17. This gives us 0.0755. So we're getting closer, much closer to our significance level, which is 0.02. So let's try x is less than or equal to 16. So probability that x is less than or equal to 16, that's going to be 1 minus the probability that x is greater than 16. So that's 1 minus, that's 20, choose 17, multiplied by 0.95 to the power 17, multiplied by 0.05 cubed, plus 20, choose 18, multiplied by 0.95 to the 18, multiplied by 0.05 squared, plus 20, choose 19, multiplied by 0.95 to the power 19, times 0.05, plus that 0.95 to the power 20, 0.95 to the power 20. Alright, so let's evaluate this. Let's punch this into the calculator. The probability that x is less than or equal to 16, and this is 0.0159. So this 0.0159, let's compare it to our significance level. It is in fact less than our 0.02. So it's less than 0.02. So we can conclude that our rejection region must be x is less than or equal to 16. Alright, therefore rejection region is x is less than or equal to 16. So we're going to reject h naught if x is less than or equal to 16. And so notice that we took the first value to dip under our significance level. So when you are given your final answer, the two values that they need to see you calculate are the first value to dip under the significance level, which in our case is x is less than or equal to 16, and the value that's just outside of our significance level, which in our case is x is less than or equal to 17. because at x is less than or equal to 17, we got 0.0755. Then we went to 16 and we got that this is just within our significance level. So this method that we use to find our rejection region is called trial and error. So if you want to find your rejection region, you use the trial and error method, where you keep evaluating probabilities until you get the critical value that gives you a probability that's less than your significance level. Now let's go on to part B. Part B says find the probability of a type 1 error. The probability of a type 1 error is the probability of being in the rejection region. So what's our rejection region? It's x is less than or equal to 16. So the probability of a type 1 error is the probability that x is less than or equal to 16, which is 0.0159. Part C. Jimmy believes that the true percentage at Irving's College is 70%. Assuming that Jimmy is correct, find the probability of a type 2 error. So a type 2 error happens when we do not reject H0 when H0 is false. So in which region are we not going to reject H0? We're rejecting H0 in the region x is less than or equal to 16. So it means we won't reject H0 if x is greater than 16. So to get our type 2 error, it's the probability of not being in the rejection region. So it's the probability that x is greater than 16 given the corrected probability. Because remember, a type 2 error always comes with a correction in the population parameter. So we've been told that the correct probability is 70%. So we're finding the probability that x is greater than 16 given that p is 70% or 0.7. Okay, so this now means that x follows a binomial distribution with our sample size. Our sample size is still 20, right? Our sample size 20. We've just corrected our probability. So sample size is 20, our probability is 0.7. So let's evaluate the probability that x is greater than 16. So that's x is 17, x is 18. So that's x is 17, x is 18, x is 19, x is 20. So that's going to be 20 choose 17 multiplied by 0.7 to the 17 multiplied by 0.3 to the 3 plus 20 choose 18 multiplied by 0.7 to the 18 multiplied by 0.3 squared plus 20 choose 19 multiplied by 0.7 to the 19 multiplied by 0.3 plus 0.7 to the power 20 for x is 20. So let's punch this expression into our calculator. So that's 20 choose 17 multiplied by 0.7 to the power 17 multiplied by 0.3 cubed plus 20 choose 18 multiplied by 0.7 to the 18 multiplied by 0.3 squared plus 20 choose 19 multiplied by 0.7 to the 19 multiplied by 0.3 to the power 1 plus 0.7 to the power 20. And so this gives us that the probability of our type 2 error is equal to 0.107, and this here is our final answer. So that's how you find the probability of a type 2 error and a type 1 error under discrete conditions. So that's it for this video. Make sure to go through the quiz and I'll see you in the next one.